Welcome back. We are continuing our lesson on measure of relative standing. In the last two lessons, we looked at z-scores and percentiles. In this lesson, we're going to look at quartiles, outliers, and box plots, and we'll finish our section on measure of relative standing. So let's start by looking at quartiles. We have three quartiles. We have quartile 1. Let me thicken that up a little bit. We have Q1, which represents quartile 1. Then we have Q2, which represents quartile 2. And we have Q3, which represents quartile 3. So let's go find what they are. In our previous lesson, we looked at percentiles. And I'm going to go back to that page where we did our percentile calculations. And when we did these percentile calculations, we found the 25th, the 50th, and the 75th percentile. And that's over in the left-hand corner, or left-hand side, you can see that. I'm going to copy that. And I'm going to go on, let me put that back. And I'm going to go on to the next page, and I'm going to paste it. And I'm using the data set from the last lesson. Our first quartile is our 25th percentile. So the first quartile, in fact, is the 25th percentile. And our second quartile is the 50th percentile. And the third quartile, that is our 75th percentile. For the particular data set that we're looking at, our first quartile is 6. Our second quartile, we calculated that to be 12.5 in the last lesson. And our third quartile, which is our 75th percentile, we calculated that to be 22.5 in the last lesson. So I'm going to go ahead and grab these because these are part of what we call our 5-number summary. So I'm going to grab these and copy them. And if I go to the next page, actually I'm going to go one page out, our 5-number summary consists of our 3 quartiles, quartile 1, 2, and 3, and also our minimum, which is our smallest x value, and our maximum. And our maximum is our largest x value. And if I go back to the original data set, and here's the page that has the original data. On the bottom you see I have 12 data values. They number from 1 to, they number, the lowest one and the smallest one is number 1, the highest one is 30, and there are 12 of them. So my minimum value is 1, and my maximum value is 30. So for this particular data set, I'm going to go to my minimum value is 1, and my maximum value is 30. And so these values, 1, 30, 6, 12.5, and 22.5, represent data values in our data set. Now, of course, the 12.5 and the 22.5 are the average between two values. This 5-number summary describes our data. Another description of our data is our interquartile range. Let me copy this, and I'm going to go to this page over here and take a look at our IQR. Our IQR is our interquartile range. And our interquartile range, IQR, is equal to our third quartile, which is 22.5, minus our first quartile, which is 6. So in this particular set of data, our interquartile range, let's calculate this, is 22.5 minus 6, which if we do that calculation, we can do it down here, and say 22.5 minus 6.0. 6 minus 0 is 6. Make this a 1. 12 minus 6 is 6. And 1 down. So our interquartile range is 16.6. Let me grab that and put that over there. I can erase my calculation. Our next is our semi-quartile range. And our semi-interquartile range is equal to Q3 minus Q1, which we calculated, 16.6, divided by 2. And 2 goes into 16 8 times, and 2 goes into 6 3 times. So there's our semi-interquartile range. And finally, our mid-quartile. Our mid-quartile is Q3, which is 22.5, plus Q1, which is 6, divided by 2. This is our mid-quartile. And 22.5 plus 6 is 28.5. Let me move this over a little bit. This is equal to 28.5 divided by 2. And I think I'm going to shrink this entire thing down a little bit because I'm filling up the page. It's going to disappear just for a minute while I resize it and make it just a little bit smaller so I can have room for this last calculation. 28, let's see, 2 goes into 2 once, 2 goes into 8 4 times, 2 goes into 5 2 times with 1 left over, so 0.5 there, 14.25. So here we have our interquartile range, our semi-interquartile range, and our mid-quartile. Now all of this data, as well as our minimum and our maximum values, which we have here, min and max are 1 and 50, are needed to create a box plot. So let me go down and go right to a box plot. Here's a box plot. Actually, this is a special kind of box plot. I'm going to look at this box plot and we're going to I'm going to describe it, and I'm also going to explain what these dots are on the end. Let me go back because the dots on the end have to do with the outliers. An outlier is a data value that may not actually belong in your data set. It just doesn't follow the overall trend. And we know that we have an outlier if we have a value x that is greater than or equal to, well, greater than either Q3 plus 1.5 times the interquartile range, or if we have a data value that is less than quartile 1 plus 1.5, or I guess I should say quartile 1, it should be, let me make this smaller, quartile 1, it should really be minus 1.5 times the interquartile range. So basically, let's put this in. Our Q3 value, if I go back to the previous page, our Q3 is 22.5. So I'm going to go back to Q3, which is 22.5. And then we have our Q1, and our Q1, if we go back, we can see that our Q1 is 6. So Q1 is 6, so we'll put our Q1 is 6. Now we're at the interquartile range. Within the interquartile range, the very edge of it. Q1 and Q3 are the very edges of our interquartile range location. And if we go up by 1.5 times the interquartile range, or we go down by 1.5 from that point of the interquartile range, and let's get our interquartile range by going back to the interquartile range calculation. And our interquartile range is right here. It is 16.6. There it is. That's Q3 minus Q1. That's our interquartile range. So 16.6 is our interquartile range. And if we go back to check for outliers, we are going to take our, is it 16? Oh my goodness, I've forgotten. Let's double check that. 16.6, yeah. So 1.5 times 16.6, and this is 1.5 times 16.6 also. So 1.5 times 16.6. And we're going to add it to Q3 and subtract it from Q1. So here's 16.6. Here's 1. Half of 16.6 is 8.3. If we add them together, we're going to get 1.5 because 16.6 is 1 of the interquartile range, and half of that is 8.3. Add them together, we get a 9. We have 14, add 1 up. Okay, so 24.9 is 1.5 times the interquartile range. So this is a 24.9 is 1.5 times the interquartile range. That's 24.9. So let me go ahead and erase this calculation. What I'm going to do is I'm going to take these two, this bottom one disappears, I move it down. Okay, so to find out, we're going to find out is x, what x has to be greater than Q3, 25.5 plus 1.5 times the interquartile range. And if I add these together, let's see, 5 and 9 is 14, add 1 up, 4, 5, 6, 7, and 2, 4, okay, 47.4. This, anything that's 47.4 or greater is an outlier. Here we have 6 minus 24.9. What is that equal to? Well, 9. And let's see, 14 minus 6 is 8, and 1 down. There we go. Okay, so anything that is 18.9 or less, 18.9 or less, smaller value, and anything that is 47.4 or more is considered an outlier. Okay, so anything greater than or equal to 47.4, less than or equal to 18.9 would be considered an outlier in this data set. So if we go back to the data set from our previous lesson, which is the very bottom of this page, well, let's see, our data goes from 1 to 30, right? Our data goes from 1 to 30. So we don't have anything that's 47.9 that high. The highest it goes is 30. And here, I actually made a little bit of a mistake here. It should be negative 18.9. This is actually negative. So our smallest value is 1, so we have nothing less than 1. Okay? So we have no outliers, but this is how you would calculate your outliers. Okay? Whenever x is greater than quartile 3 value plus 1.5 times the interquartile range, or whenever x is less than, I should say less than or equal to, greater than, I guess it's just greater than, not equal to. So greater than Q3 plus the interquartile range, or less than Q1 minus the interquartile range. So I suppose, let me adjust this. It should be, in this case, it would be more than, okay, I should move this, not, because it's not equal to, more than 47.4. And that's not happening because the highest is 30. And in this case, I really should just be correct with this. Less than 18.9. And that's also not happening because the smallest value is 1. Okay? Okay, so now we know we have no outliers, but we could have outliers. All right? So we're going to look at, here's a box plot. This is a modified box plot. What makes the modified box plot modified is that it has dots for values that are outliers. Okay? And it can be an asterisk or a dot. It's your choice. Okay? Now in this particular case, well, we don't have any outliers, so we don't need a modified box plot. We can just use a regular box plot. And the way that a box plot works is we create a line such that the end of the line represents our minimum value, the left end, and the right end represents our maximum value if we removed outliers. Then this box, well, one end of the box represents our quartile 1. The other end of the box represents quartile 3. And then the middle of the box, we have this line. This is quartile 2. And this length of the box is equal to the interquartile range. So what you need to do is you need to calculate your 5-number summary, which is your minimum, your maximum, and your quartile 1, 2, and 3, and you can create your modified box plot. If you have any outliers, those would be added as dots. Let's finish this lesson by adding a page below. And what I'm going to do is create a box plot for the data that we have analyzed. So we're going to create our own box plot. And what we need for our box plot is we need the 5-number summary. So I'm going to go back to our 5-number summary page and grab our 5 numbers, which are our min, our max, and our quartile 1, 2, and 3. I'm going to copy that. And then I'm going to go back to this last page, which is our box plot page. And I'm going to paste the 5-number summary. It's going to show up in just a minute. Well, I can put it right here. Here we go. All right. So our smallest value is 1 and our highest value is 30. So I'm going to draw a line. We'll do our box plot in blue, so it's a different color. So I'm going to draw a line from 1 to 30. Here it is. This represents 1. This represents 30. Now I'm going to put in a couple of guidelines to help me that I'm going to remove later. I would say my halfway point is about here. And so if it's 30, it's 15 to the left and 15 to the right. So I'll subdivide it into thirds. So this would be 5, 10, 15, 20, 25, 30 on the end, more or less. Okay. So let me just erase this a little bit so I can mark it out. So this would, well, I'll erase a little bit more. Get a little bit more room for writing. Okay. So this would represent the x value of 5, 10, 15, 20, and then 25. And of course 30 is on the end. We started. We're supposed to start at 1. Okay, so, well, this would be 0. Imagine it's 1, so it's a little bit shifted to the right. We'll pretend that we'll call that a 1. And then this is 30. Okay, so what I want to do, I'm going to go back to blue. And I have my 2 endpoints represent the min and the max. A min of 1 and a max of 30. Those are the 2 endpoints. My 6, well, 6 would put me about right here. So that's my 6. That's the left end of my box. The right end of my box is 22.5. Well, let's see. 1, 2, 20, that's about halfway between. So there's 22.5 be right there. Actually, a little bit more to the left. It's halfway between 20 and 25, halfway point. And then 12.5, let's see, 10, 11, 12, that's about halfway here, right? So my box is going to start at Q1 and make it out to Q3. So let me draw the box. It's going to start at Q1. It's going to go all the way out to Q3. Here's the box. It should straighten out. Okay. And let me center the box. I'm pulling it down a little bit. It should be centered. And then I'm going to have a line right at Q2, Q2 at 12.5. That line, that's also, that's my middle value. That's my 50 percentile. Okay, so I'm going to get rid of the black. I have these lines. Hopefully I can grab them okay. If I made my box too big, trying to grab these lines with black. Let me move my box up a little bit. The whole thing. Okay, let me move my box up just a tiny bit so that I can remove these guidelines. The black these were guidelines to sort of help me along. So I'm going to get rid of the 1, 5, 10, 15, 20, 25, 30, and we don't actually need these, and those will disappear while I cut them out. Okay, and now I'm going to move my box plot down. It really should be centered. So I'm going to go ahead and grab my box plot. Let me move it down a little bit. There. Okay, so here's my box plot. And my interquartile range is the distance from one end of the box to the other. That's my interquartile range. So this is all for the data that I just collected. My minimum value, this should be set up so that it's almost like you have a ruler on here. You really want these distances to be proportional. That's my minimum x value. That's my maximum x value. This value here represents my quartile 1 value, Q1 value, which is the 25th percentile. This represents my Q3, which is the 75th percentile. And this right here represents Q2, which is my 50th percentile. So this is how you create a box plot. So this is the end of our lesson on the last part of measures of relative standing, where we covered quartiles, quartile 1, 2, and 3, outliers, and constructing a box plot.